Ever thought about what the universe's most abundant, yet most elusive particle might be? Welcome to the enigmatic world of neutrinos, the universe's ultimate hide-and-seek champions. These subatomic particles are the cosmic phantoms that dance through the cosmos, barely interacting with anything else. They have a knack for being everywhere and nowhere at the same time. Imagine a particle so small, so light that it's almost weightless. That's a neutrino for you. These particles are so incredibly tiny that their mass is nearly zero. Not only that, but they're also neutral, meaning they carry no charge. This lack of charge is what makes them such elusive characters. Without a charge, they can pass through matter without getting caught up in the electromagnetic forces that govern the interactions of most particles. And when we say they pass through matter, we mean a lot of matter. Every second, trillions upon trillions of neutrinos pass through your body, the Earth, and even the Sun without a care in the world. They're like the ultimate cosmic tourists, traveling at nearly the speed of light and stopping for nothing. But here's the real kicker. Despite being so abundant, we know surprisingly little about them. They're like the enigmatic strangers at a party, mingling with everyone yet revealing nothing about themselves. They play by their own rules, dancing to a tune that we're still trying to fathom. So, what's the deal with these ghostly particles? Why are they so hard to pin down? And why should we even care about them? Well, as it turns out, these seemingly inconsequential particles could hold the key to some of the biggest mysteries of the universe. They could help us understand the inner workings of stars, the formation of galaxies, and even the very nature of matter itself. These ghostly particles, despite their abundance, remain a mystery wrapped in an enigma. But as we delve deeper into the world of neutrinos, we're beginning to unravel the secrets they hold. So, buckle up, because we're about to embark on a journey into the heart of the neutrino enigma. You might be wondering, if neutrinos are so abundant, why don't we hear more about them? Well, it's not because scientists are ignoring them. Quite the opposite. It's primarily because neutrinos, despite their prevalence, are notoriously elusive. They're often tagged as useless particles, and there's a smidgen of truth in this, but only because we're looking at them from our human perspective. Neutrinos are subatomic particles with no electrical charge, and they only weakly interact with other matter. This makes them incredibly difficult to detect and study. Every second, trillions of neutrinos pass through your body, and yet you don't feel a thing. They're like cosmic phantoms, constantly slipping through our fingers. Imagine trying to have a meaningful conversation with someone who never responds, barely acknowledges your existence, and just passes right through you. It's a bit like that with neutrinos. This lack of interaction also makes them practically impossible to harness for any practical use. At least according to our current understanding and technology. You can't just collect a jar of neutrinos and use them to power your car or charge your phone. They're not like electrons, which we can manipulate to create electricity. They're more like cosmic whispers, hinting at the secrets of the universe, but never revealing them outright. And it's not for lack of trying. Scientists have built massive detectors deep underground, shielded from cosmic rays, in a bid to catch these elusive particles. They've watched as neutrinos from the sun and from supernovae pass straight through their detectors, leaving barely a trace. It's a bit like trying to catch smoke with a net. So, are neutrinos useless? From a practical human perspective, perhaps. But from a scientific perspective, every particle has its story to tell, its secret to reveal. And neutrinos are no exception. In the grand scheme of things, neutrinos might seem like the universe's most introverted particles, hiding in plain sight. Despite their elusive nature and apparent uselessness, why do scientists dedicate their life's work to studying neutrinos? Well, to answer that, let's delve into the scientific significance of these seemingly insignificant particles. Despite their reputation as the ghost particles of the universe, neutrinos hold immense potential to unlock some of the most profound secrets of our existence. To start with, neutrinos are the most abundant particles in the universe, outnumbering even atoms. They're constantly streaming through space, right through our planet, and even through us, hardly ever interacting with other particles. This elusive behavior makes them incredibly difficult to detect, but it also gives them the unique ability to carry information from places that are otherwise unreachable. For instance, let's consider the sun. Much of what we know about the sun comes from light that it emits, but light can't penetrate the sun's dense core, where nuclear fusion takes place. Neutrinos, on the other hand, stream right out of the core, carrying with them information about the processes occurring there. By studying solar neutrinos, scientists have been able to confirm theories about how the sun, and by extension, other stars, work. But the significance of neutrinos goes beyond just the stars. These particles could also help unravel the nature of dark matter. one of the most puzzling aspects of the universe. Dark matter doesn't interact with light, which makes it impossible to observe directly. However, if dark matter interacts with neutrinos, studying these interactions could provide crucial insights into what dark matter is made of. Moreover, neutrinos could hold the key to understanding the origins of the universe itself. Moments after the Big Bang, the universe was flooded with neutrinos. These primordial neutrinos, if we could detect them, would provide a snapshot of the universe at its birth. So, while neutrinos might not be useful in a conventional sense, their scientific value is beyond measure. They're not just ghost particles drifting aimlessly through space, they're cosmic messengers carrying secrets of the universe waiting for us to decipher. So, where do we go from here with neutrino research? As we delve deeper into the enigma of neutrinos, the future beckons with a myriad of fascinating directions and tantalizing possibilities. One of the most exciting areas of focus lies in the development of cutting-edge technologies and methodologies. The neutrino, elusive as it is, requires some of the most advanced and innovative tools to study. We're not just talking about super-powered telescopes or massive particle accelerators. We're talking about experiments like the Ice Cube Neutrino Observatory, a gigantic detector buried deep within the Antarctic ice, or the Hyper Kamiokande in Japan, a supermassive water Cherenkov detector. These aren't just fancy names, they represent the pinnacle of human ingenuity in our quest to understand these ghostly particles. The future of neutrino research is also set to delve deeper into the mysteries of neutrino oscillation. This strange quantum phenomenon where neutrinos change their flavor mid-flight could hold the answer to some of the universe's most profound questions. Are there more types of neutrinos we haven't discovered yet? Do neutrinos play a role in the elusive dark matter? These are just some of the questions that scientists hope to answer. And it's not just about answering the big questions. Neutrino research has the potential to revolutionize other fields as well. For example, neutrino tomography could provide us with a new way to probe the Earth's interior, revealing secrets about our planet that have remained hidden for billions of years. The world of neutrinos is also set to become more accessible to the public, with initiatives like the Neutrino Energy Group working to harness neutrinos as a new form of renewable energy. The useless particle could soon become a household name. The journey of understanding neutrinos is far from over, and the road ahead is filled with exciting possibilities. As we step into this brave new world, one thing is certain. The neutrino, with all its quirks and mysteries, will continue to captivate and inspire us for generations to come. So, are neutrinos really useless? Well, that's a question that may lead us down a rabbit hole of profound scientific inquiry. As we've journeyed through the enigma of neutrinos, their perceived uselessness, their significance, and the future of neutrino research, we've discovered that these ghost particles are anything but ordinary. In our everyday lives, neutrinos may seem to play no role. They pass through us, through the Earth, without leaving a trace. They're there, yet they're not. They simply exist, without apparent purpose or function, and yet the universe is teeming with them every second of every day. In this sense, they might indeed seem useless. But let's take a step back and look at the bigger picture. The universe is a grand tapestry of mysteries, and neutrinos are a crucial thread in that tapestry. They're a testament to the universe's complexity and diversity. They're a reminder that not everything in the universe is meant to have a direct, tangible impact on our lives. In the realm of scientific research, neutrinos are anything but useless. They're a golden ticket to understanding some of the most profound secrets of the universe. They offer insights into the nature of matter, the workings of the stars, and the origins of the universe itself. They may not build bridges or cure diseases, but they help us understand the world we live in. And there's an inherent value in that. So let's embrace the useless. Let's appreciate the neutrinos for what they are, a beautiful and mysterious part of our universe. They may not change our lives in a practical sense, but they enrich our understanding of the cosmos. They challenge us to think, to question, to explore. They remind us that there's always more to learn, always more to discover. Neutrinos, the ghost particles, may seem useless, but they hold the key to understanding the universe's greatest secrets. So next time you think about useless things, remember the neutrinos.